technical difficulties yesterday with the Instagram live. I think we better today. It wasn't letting me save my videos, and when I saw them on my story, the video quality wasn't that decent, but I think that it might be working again today. It might be back properly working today. So, cool. But, we learned to adjust and adapt. And if it hadn't worked properly, we would have just found another medium to go into to broadcast this work so that y'all could get this instruction. At any rate, welcome to All This Math. This is Professor Parker. And today we're going to solve, well, today we're not solving anything. Actually, we're going to write an equation, right? So first thing we're going to do is, when we see a problem like this, we just take our time and just read it and just try to fully understand what's going on up here, right? So we read it and it says, write an equation of a line. But wait, what does this symbol mean? This is something from geometry, right? This means parallel. That's a symbol for parallel as opposed to perpendicular. Perpendicular is denoted by the upside down capital T. This means parallel. So it's like two lines that are like, boom, parallel, right? Parallel to this line, right? X plus 2y equals 6, and passing through the point 8 and 3, all right? So we're not going to really draw the graph, but just imagine that we had a coordinate plane like this, right? That's your y-axis, that's your x-axis, and if it goes through this point, just wonder, like, where would that point be? At 8, 3. So 8 would be your x value, 3 would be your y value. So let's say you go over here 8 and go up here about 3. So that would be your point 8, 3, roughly, right? But we want to find an equation of a line that's parallel to this line and it passes through this point. So whenever you see a question like this that talks about an equation of a line that's parallel to something or perpendicular to something should trigger in your mind. You should start thinking about the slope of the line that you're given, all right? So that means we need to figure out what the slope of this line is. Now, it's not just given to us straight up, but we can figure it out. First thing we need to think about is, like, what form is this equation written in? It could be written in standard form, it could be written in point slope form, or it could be written in slope intercept form. This happens to be written in standard form. And how do I know that it's in standard form? I know it's in standard form because my x value and my y value are both to the left of the equal sign and have a constant to the right of the equal sign. So that's called standard form. Now, in order for me to find the slope, what I could do is I could either convert this into slope intercept form, which would be y equals mx plus b. So basically all I do is I would just subtract x on both sides and then divide by 2 throughout the whole equation in order to solve for y, essentially. So I'd have y on the left and everything else on the right side, right? That's one option. Or I'm gonna put you onto this. Whenever you have an equation of a line in standard form, there's a formula that you can use to find the slope using the coefficient of the x term and the y term. Now, you should write this formula down and then use it a whole bunch of times. And after you start using it, when you encounter problems like this, you'll end up memorizing the formula. So the formula for the slope when the equation is in standard form is this: negative a over b. So m equals negative a over b. All right. Now, you should be wondering, well, what is a and what is b? I don't see no a and b up here. All right, cool. The a is the coefficient of the x term, or the number that's written next to the x term. Now, I see no number written here. That means that there's an invisible 1. It's understood to be 1. X is the same thing as 1x. X is not the same thing as 1, but if someone asks you how many x's are there, you would say, well, there's 1x there. So therefore, the coefficient of x is a 1, even if no positive 1 is written here. So that means I go to my formula. And since a is 1, my formula says negative a. So I do negative 1, like that. Now b, you might have already figured out, b will be the coefficient of the y term. Now in this problem, y is 2. Well, no, not y is 2. B is 2. In this problem, b is 2. So I just put that in my formula. Now, then I ask myself, can I reduce this fraction? I say no, it's already reduced. So that's the slope, right? Now, we're looking for the equation of a line that's parallel. Now, if two lines are parallel, we have to ask ourselves, how are their slopes related to each other? If two lines are parallel. If two lines are parallel, their slopes are exactly the same. Remember that. Write that down. If two lines are parallel, their slopes are exactly the same. Now, we get to the problems where you see a upside down capital T, or the lines are perpendicular, then the slopes are different. The slopes are going to be negative reciprocals of each other. And that requires a little more work to do to figure out what the slope of that line is, right? It's 2 steps. You got to change the sign of the first slope and flip it upside down, meaning take the reciprocal. So you got to do those 2 things, all right? So, but for this one, we're talking about parallel lines. And parallel lines have the exact same slope. So that means that if the slope of this line is -1/2, then that means the slope of the line I'm looking for is also -1/2. So now, in order to find the equation, I start out with a formula. And I think I should start out with the slope intercept form. Y equals mx plus b. Right? Now, I need to know when I'm finished and I got the actual equation, I'm going to need a numerical value for m and a numerical value for b. I already have the numerical value for m because I know that's -1/2, right? I don't have a numerical value for b, but I can calculate that. I can solve for that by using this x and this y. Because remember, the equation of the line we're looking for is not only parallel to this line, but it also passes through this point. It's also going to pass through this point. So that's 2 pieces of information that are very valuable that we're going to use to find out what we're looking for. So then what I do is I take the y from this point, which is 3. I write my equal sign. I take the m that they have. M is the slope. M is -1/2. And then I'll multiply that by x. X is 8. And then I have plus b. Now, I don't know what b is, but we're going to solve for b. So the first thing we do is on the right side of the equation, we're going to simplify this part. -1/2 times 8. And that is -4. So we see how we got -4 from -1/2 times 8. Because that's -8/2, which simplifies to -4. Now we want to solve for b. We want to get b by itself on the right side. So we want to get rid of this -4. So we want to do the opposite of -4, which is add 4. +4, +4, 3 + 4 is 7. 7 is equal to b. So 7 is equal to b, right? So now we know what b is. So now I can write my equation, right? And I'm basically done. So I go back to this general form, right? Or this formula. And I write y equals -1/2 x plus 7. Now I could leave my answer like that and just be like, okay, I'm finished, draw a box around it, and I'm done. But I think that I'm not done. Because remember, the original equation was given to us in standard form with the x and the y on the left side of the equal sign and a constant on the right. This is not standard form. This is slope intercept form. So I think what I want to do in order to give the best possible answer, because in a problem, if you're given information within a problem in a certain form, you should give the answer in that same form. So if I'm given this in standard form, I probably shouldn't give them the answer back in slope intercept form. I should probably give them the answer back in standard form also. So that's what I'm about to do. So the way to do that is basically just move the x term to the left side, right? Or transpose it. So then I'm going to have plus 1/2 x. So then I have 1/2 x on the left. I still have positive y over here. And now I just have 7 over here. Now another thing about standard form is that our coefficients will never be fractions. All right? So I need to convert this 1/2 into a whole number or into some type of integer. So in order to get rid of the 1/2, I'm going to multiply the whole equation by 2. So I do 2 times 1/2, which gives me 1. So that's going to give me an x. And then I'm going to do 2 times y, which gives me 2y. And then I'm going to do 2 times 7, which gives me 14. So now this is equivalent. This is equivalent to this right here. X plus 2y equals 14. And one other thing I can do, just to be even more technical and even more sure that my answer is correct, one other thing I can do is I can take this point and substitute it in and make sure that this point is actually on this line. Because if I take the values or the numbers within this point and I substitute them into this equation and the left side equals the right side, or it yields a true statement, then that means that this point is on that line. So if I do 8 plus 2 times 3 equals 14, then I got 8 plus 6 equals 14, and then I got 14 equals 14, and that's a manifestation of the reflexive property. So that's our flex, basically. So we flex because we got the answer correct. But this is the actual answer right here. X plus 2y equals 14 is the equation of the line parallel to this line that also passes through this point right here. All right. So these types of questions you'll see on the SAT. These types of questions you'll see on the ACT. These types of questions you'll see in an Algebra 1 class, maybe an Algebra 2 class, maybe even in a geometry class, because this is called coordinate geometry, coordinate plane geometry. That's what that's called. Because remember, this symbol, this is the symbol for parallel lines. This is a geometric symbol. So you see the merger between algebra and geometry, right? Just because you get out of an algebra class and you feel like, oh, I'm in geometry now, you can't escape the algebra. You need to master the algebra. Once you master the algebra, then you can do geometry. It'll be easy. You can do the trig. You can do the calculus later, the pre-calculus, even the stats, right? But this you might also see in a geometry class. But at any rate, thank you for tuning in. Please continue to send your problems to the All This Math DM, and it might make it onto this board. Peace.